Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Thank you, everyone. Welcome to today's webinar brought to you by the Oxygen Alliance. My name is Roy Kaembe. I'm a biomedical engineer working with Oxygen Alliance, and I'll be your host today. I'm joining this call from Malawi in Lilongwe, and I will be interested to know where everyone is joining us from. So just write your name and where you're coming from, where you're joining us from in the chat. Yeah, and if you would like to receive communications on upcoming webinars and events from the Oxygen Alliance, please may you type your email address also in the chat so that we can add you to our email list. Yeah, so today we're going to continue our sessions on sterilization sterilizers webinars by focusing on technical repairs and troubleshooting for tabletop autoclaves. So our presenters today are Mr. Daniel from Kenya and Mr. Bonongwe from Malawi. And these presenters have a vast hands-on experience in maintenance of steam sterilizers, and I'm very excited to learn more on the maintenance of tabletop autoclave. So I encourage everyone to take notes, and as all questions and comments will be addressed at the end of the presentation. During the call, we'll share a feedback form. So make sure that before you leave the call, you fill in this feedback. It really helps us to improve the webinars that we conduct. So please make sure that you fill out this feedback form before you leave. So without wasting much of the time, please let me welcome our first speaker today, Mr. Daniel. So shortly, I'll just share the presentation and I'll give the floor to Mr. Daniel.
Thank you, the participants. I'm presenting on technical repair and troubleshooting of the tabletop autoclaves. The tabletop autoclaves, they come in different types, and they are usually placed on the table, hence acquiring the name tabletop autoclaves. They are usually used to sterilize instruments and other materials that come into contact with the catchers or samples. And as you can see in the picture, they come in small size, in compact size. That means it is easily portable. They are also easy to use. So as you can see the external parts of that tabletop autoclave, we are checking this one on the picture. You can see the main parts. We have the door. All this is the door. We have the door switch. The door switch is usually inside the unit. You are not able to see it externally. Then these are the handles. There are two. And you can see this black insulation. It is heat resistant cover, this one. We have a reset switch here, or a function regulator. Maybe you would want to select what you need here. In case you would want to drain the water, you can use this drain valve here. Then we have the timer. You would want to time the sterilization cycle. Is it 121? You time it for 15 minutes, or is it 104? You time it also. Then here you can see this is a gradual adjustment. If you go anti-clockwise like this, you are increasing the rate of pressure and temperature. If you turn this knob to that direction, you are increasing this pressure and temperature. If you come to the clockwise direction, you are reducing the setting of the pressure and temperature. This is the pressure gauge. If you are operating, let's say you have selected 121 degrees, the pressure here, the pointer will move up to between 121 and 126. So this pressure gauge is used to see what are the what pressures as the unit reach. So here is where you put in the water. This is just a cover. You remove this cover and you put water inside here. When you open out the cover, you will find the internal parts. So here you have the display board. Here you have the door gasket. This one here is the door gasket. This is made of silicone material because it's said that it will withstand very high temperatures. Thank you. Within the electric heating.
Hi, Daniel. It seems like you are breaking up. If you can hear me, try to fix your network.
Okay.
Yeah, now we can hear you properly.
Okay. When within the electric heating element, here we have the temperature sensor. Here it's mounted within the element here. In case you dry boil, you run the unit without water, this will be able to sense the temperature of that heater. Here we'll be able to check the water level here. There's another sensor here. Then inside here, this is the chamber. This is the chamber. Inside here, inside this unit here, there are the filters here. This is a filter, the front one, and there is also the rear one. There's another filter like this rear. So inside this part, we have the trace. These are the trace. Then when you come here also, is here is called the solenoid valve. All these from this place up to this place up to here. This is the solenoid valve. These are the crocodile clips, which is used to tie to put on the silicone tubing to this solenoid valve. If you would want to check the voltage of this solenoid valve, you read here, which is normally 1240 volts, 5 watts. It is very important for you to know the voltage and the watts. The solenoid valve, once you switch on the unit, the solenoid valve will be energized and it will allow the flow in that direction. So when the engineer is also installing this solenoid valve, it is very important you check the arrow or the direction. At the other side, the arrow is indicated. So if your water is flowing in from this direction to this direction, the arrow will face the same. So these are the silicone tubings. This is the display board here. Allow me to expand it. Sorry. This is the display board here. This is the display board, the PCB board. Then here, it's not very clear. There is the micro switch here. I hope you shall be able here. There is the micro switch for the door, although it's not quite very clear. And then this is the fiber, which is connecting the motherboard and is connecting this board here. This board here is connected to this. This fiber here is connecting the main PCB board, this one, to the display board. So here we have the thermostat. The most important part in this unit here, it is the thermostat, which is graduated in terms of degrees. So the most important here, there is a stopper. Here there is no further you can turn this knob. This knob you can turn it to that direction. So once it reaches the maximum, it is around 200 degrees here or 220 degrees. So it is very important for the engineer to make sure you understand the setting of this knob. Where is it set? These are the electrical wires, and these electrical wires, the cross-sectional area is very important, 2.5 millimeters squared. These wires, they are heat resistant together with these ones here. These wires are heat resistant because they'll be able to withstand the heat. This is the main, the power board. This is the main power board, as we had said. Here is also not quite clear on my picture here. The door switch. This is the door switch. The most important, the door switch, it has what we call the micro switch. The micro switch will be energized when the door is open. When you press open the door, the micro switch will be supplied, then the door will open. What is the safety procedures when working with the top autoclaves? The side from the user should not clean the equipment using jig. Jig is corrosive, so you use Hibitin, or you can use 70% alcohol. The user should not splash the equipment with water. Do not operate the equipment with wet hands. That can lead to electrocution. The user should not run the equipment without water. That is what we call dry heating. Always check the water before any cycle start. The user should not overload the equipment. When you overload that equipment, your packs will come out wet. So this is very important for the user. Always read the user manual. Do not open the equipment when it's on. This is very important. And as we saw the pressure gauge, when there is pressure, the pointer is indicating at 121. That means there is pressure. There are some autoclaves when you open when there is pressure, they will not open. But others, if in case it opens, it's very dangerous to the user. Only open the door when the pressure is at 0. Very important. Do not operate in a wet area or environment. I think we have talked about that. The user should or select the required sterilization cycle, depending on the material to be sterilized. This is very important. Do not leave the machine unattended. That means the user has switched on the unit and then the machine is working alone. The user is not near the equipment. This is very important. For the side of the biomedical engineer or the technician who is coming to repair there, do not clean the equipment with jig. As we say, jig is corrosive. Instead, here you can use 70% alcohol for the disinfecting the equipment. Do not splash the equipment with water. In case you are wiping out after you have used the alcohol, maybe you are using soapy water to clean the equipment, let this water not splash to the equipment. Do not touch the equipment with wet hands, also the engineer, because of it will electrocute you. Dust the equipment with less water. Always use distilled water and at the correct level. This is very important because if you use any different, there will be formation of scaling within the electric heating element, the immersion type. So when you use distilled water, the deposits will be minimized. The scaling will be minimized. Do not plug the equipment. Sorry, this was supposed to read multi-socket, but use an industrial socket. The reason why you don't, should read multi-socket. The multi-socket is the socket extension, which are several socket outlets. The reason why this socket, the current rating of this socket is lower than the one used by the autoclave. So that's why when you connect this equipment to a multi-socket, you'll find the outlets are burned because the current rating for the equipment is very high. Do not plug the equipment to a different voltage apart from the one indicated. This is very important for the engineer. Avoid using the wrong tools. Here, some of our engineers, they are using pliers to open the screws. This is not allowed. Do not use the wrong grease. At the door opening, that door mechanism, there is a part which enters inside as you close the door. That part, after every 6 months, you need to grease it using what we call the silicone grease. Do not use the wrong contact cleaner. This is electronic contact cleaner. Here we have put the recommended tools. You need, an engineer should have a complete set of star, flat, screwdrivers, both flat and star. You should have an Allen key set. What I would want to mention here about the Allen key set, here, when you see any Allen key is labeled in metric, in millimeters, that Allen key or that tool, it is metric. But at any one point you'll find the same Allen key, it is labeled in fraction. Let's say this is 3/4. Let's say this is 5/8. It means this Allen key is imperial. So it means, for example, if you are using an Allen key is 3.5 millimeters and you use an Allen key which is 3.5 millimeter, if it is metric, it is open that Allen screw. If that Allen screw is imperial and you use metric, this metric will not open that Allen bolt. So you have to use what we call an imperial Allen key. So this is very important for our engineers here. This is a ratchet. The ratchet has what we call the socket. The The socket, they are labeled also in terms of millimeters. So they are also here. Within this box spanner set, there is the ratchet, there is the extension. The extension is here, and then we have the socket. These sockets are labeled also in this formula. The same applies to imperial and metric also here. The ratchet is here, the extension is here, and then the sockets are here. They are labeled. If you would want to know the size of this, you just read within the body here. You get the size, the smallest. Here is what we term them as, this is a combination spanner. It is combined, this one side is open and this one side is ring. So this we call a combination spanner. So it will start from number 6, number 8, number 10, like that up to number 22. Very important. The reason why you have these different set of spanners, different manufacturers will make those tabletop autoclaves with the different screws, different bolts, different nuts of different sizes. So it is very important as an engineer, you must have a set of these. Materials used is very important. The materials used. Teflon thread, it's here. Cable ties, they are here. And we normally use these cable ties, they come in sizes, they small, medium, and large. So in case of this, you can use medium ones or you can use the small ones. And they also come in different colors. Do you like white? Do you like gray? Do you like black? Do you like red? They come in different colors. Silicone grease is not within our picture here, but silicone grease, we use it to grease the door mechanism. The silicone tubes, we saw them during the part of the autoclave. But what I would mention here, make sure you replace using the same size of the cross-sectional area of this silicone tube here. Crocodile clips, you saw it there. Electronic contact cleaner. Most of our engineers, they don't use this. Any engineer who is working on any electronics, you must use this. How do you use this? When you open the unit, you'll find the electronics is very dirty. So first you'll use a brush. Either the brush can be 1 inch or that black top in here. You connect it here. Once you connect it here, that means you can enter or you can spray the areas you may be not able to reach. This connector here. So nitric acid, this is nitric acid to water. That is the ratio. Maybe when you are descaling, you use 1:10. You can also use when you are descaling, you can use what you call acetic acid. Then you need to clean the unit. Once you used the alcohol in the disinfection from the start, you can use soapy water. You can use gauze. The gauze is here. And you can see there is these scissors. Once you get this gauze, sometimes it comes in a roll. So you need to cut it into small pieces, like this one. You cut using the scissors. So as an engineer, when you are going to repair these autoclaves, what are those materials an engineer should be able to carry? Here we have also left out the gloves, the clean gloves. You need to add whatever is missing. So, but majorly, this is what all the materials required for an engineer to service those autoclaves. The maintenance procedure, you would want, the equipment is not working. How will you repair that autoclave? First, you get the problem from the user. The user will tell you, this equipment happened, this and this. If in case there is an error code. So here, the engineer has to be very well versed with the user. The PR between the user and the engineer is very important. For one to be able to get all the information between the user and the engineer. In case there is an error shown within the display, then there is an error code. And that error code, maybe it can show 01, 02, 03. That particular error code, it means maybe there is no power, there is no water. So that's what we mean by error codes. After that, the engineer should be well versed with the user and the technical manual. Use user shock technical manual. Here there is a comma, there is a user manual and there is the technical manual to understand the equipment operation. Most of our machines, when they break, the engineer should be able to understand the user manual. Before you give your technical advice or before you repair the equipment technically, you need to understand first the user. Correlate the error with the manual. The error you have seen there, can you check with the manual whether the manual is saying what is the problem? within the manual. If in case you are not able to understand, most of the errors are not within the manual. We are requiring the engineers to make consultations. Most errors or faults are not in the manual. In that case, you do what? You consult. Understand the sterilization sections. Within the unit, these sections are classified. There is the electrical circuit, which consists of the power cord, the main PCB, the display board. After that, there are other sections within that equipment. The gadgets are the solenoid valves. We have the temperature sensors. We have the thermostat, as you saw. We have the door. We have the solenoid valve. We have the door locking mechanism. And then we have the tubings. So in case this equipment has a problem, if the problem is electrical, deal with the electrical part. If the problem is mechanical, deal with the door mechanism, the door mechanism. If the problem is within the leakages, deal now with the tubings. Maintenance checks, clean the equipment, check the equipment support. Maybe one of the support is missing, so it means the equipment is not well placed or well positioned. And if the equipment is not well positioned, the water will come out. The water will not attain its level. So this is very important. Check the water pressure. The incoming water pressure, we usually use 4 to 6 bars. The rising main, which is the water which is supplying your equipment, what is the pressure of that water? If the pressure is low, then it means the water will not be able to enter to the equipment. In case your unit is connected to the main supply, then you must make sure the pressure, this is the minimum setting of pressure, and this is the maximum setting of the pressure. If it is manually, you open that cover we saw there, the yellow one, then you pour in water, checking the maximum level. Ensure proper electrical connections. Make sure, especially here, the earthing is very important, the earthing. Ensure storage tank has a full water capacity. This is daily checks. Preventive maintenance tasks. Clean the equipment using 70% alcohol. In that case, you are disinfecting the equipment. Clean with the soapy water inside and dry. Usually, we avoid this where we have electrical parts. Remember, when the equipment is working, there is a presence of electrical sparks. So when you clean the equipment inside with alcohol, alcohol is very flammable. So there can be risk of fire. So that's why after inside it, you use soapy water inside. Clean out dust with the brush. Clean the electronics with the electronic contact cleaner. Clean the filters with the brush and soapy water. Where you saw the filter housing, once you open that housing for that filter, there is a metallic filter. So that filter becomes dirty. So these filters, you're using a brush and soapy water, you need to clean those filters. Tighten the crocodile clips. We design these crocodile clips. This is clips, not chips. Sorry for that. Crocodile clips. So sometimes these crocodile clips get loose, so we request them to tighten them. Replace worn out silicone tubings. Grease the door shaft using the silicone grease. Then test the safety switch. The safety switch is within the rear of the equipment. Thank you, participants. If you have questions, maybe I'm ready for questions. Thank you.
All right. Thank you, Engineer Daniel. So as I said, questions will be taken at the end. So right now, I will hand it over to the next presenter. But then, before the next presenter, I would like to take this opportunity to briefly introduce you to the BME Konza app that we have developed here at Oxygen Alliance. So it's an Android app that we built to assist biomedical engineers and technicians in the work that they do. So it contains service manuals, as Engineer Daniel was saying. Sometimes you need to convert. So the app also has the feature that you can actually ask questions on the app, and fellow engineers can actually answer. So to install it, so just go on Google Play Store and search BME Konza, and you'll be able to download it. Or here in the chat, a link will be pasted so that you can actually access it just at the end of the call. So right now, let me hand over the presentation to Engineer Bonongwe. to continue the presentation. Thank you so much. And thank you, Daniel, for the wonderful presentation.
Thank you.
Thank you very much, Lloyd, for giving me the floor. And I'll take you through the common problems or the common faults that may occur in our autoclaves. But just as a continuation to what Daniel presented, I will take you through the scaling. That is the process of removing some scales in the chamber, especially on the element. So what we use is nitric acid, which is in a ratio of 1 to 10, or you can also use acetic acid. And how do you do the mixture? Is you mix it with warm water and allow the mixture to settle for 20 minutes. Then you clean out the scales. You wipe up the chamber with distilled water after everything. Let me also take you through the most important parameters that we need to have in the autoclave. For the autoclave to operate properly, we need to have temperature. Then we need to have pressure for easy penetration into our materials. And also we need the sterilization time. So the absence of one of these parameters will cause the malfunctionality of the autoclave, or the autoclave will not sterilize. The temperature sensor is also an important component, just because it is the one that regulates the temperature. We do have also the pressure switch inside the autoclave, and this pressure switch or pressure sensor regulates the sterilization pressure, and the timer controls or regulates the sterilization time. There in the peak, we are able to see the types of autoclaves. We are seeing the pressure cooker type, the vertical, and we have the tabletop, I think, on which we are presenting. And we have also the horizontal industrial autoclave, and we also have the large automatic hospital autoclave. Now we are into troubleshooting of the common problems that may occur in our autoclaves. We do have a lot of problems that may occur in our autoclaves, but we have selected a few that are commonly occurs or that we commonly encounter in our particular day-to-day troubleshooting of autoclaves. So the first one is steam leakage. If you may have steam leakage, that steam leakage can be caused by a loose gasket or a damaged gasket. Or we may have some loose connections on the pipes, or that is on the joints. So the solution to this is to fix the leakage by replacing the damaged gasket with the same size of gasket. We may also have overheating in our autoclaves that may be caused by malfunctioning of the temperature sensor, or we are having a clogged heat exchanger. So the solution to this is to replace the temperature sensor and clean the heat exchanger. In the picture there, we are seeing a component which is the temperature sensor. That is when you want to fix the problem of issues to do with temperature. If anything is to go in the direction that temperature is not rising, temperature is too low, then what we are supposed to look into is the temperature sensor. And if you have leakage in the autoclave, then you first go straight to the door gasket, which is in the peak, and also the connections where you can just do tightening of the connections to solve the problem. Another problem is long overheating period, or no heating at all. That can be caused by the damaged heating element. So as a solution to this, you test the element. If it is not okay, replace the damaged heating element. And this might also be caused by the power supply problem, that the element is okay, but the power being supplied to the element is missing. Then what you are supposed to do is to check the power supply to the heating element. That is by testing the relays, or others may have magnetic contactors. So test those. If they are not okay, replace them. Here we are having different types of elements, heating elements for desktop tabletop autoclaves. They may come in different particular sizes, but what we need to be checking on them is the size, like the wattage, that is the power rating, and the voltage. and also the current rating. If you are replacing them, make sure you look on those particular specifications. Don't miss them, because you might replace that heating element with a long type of heating element that will affect the functionality of your autoclave. Another fault is goods not properly sterilized, and that is causing a biological indicator not to change color. This can be caused by insufficient steam pressure and temperature. And it can also be caused by less sterilization time. So as a solution, check the temperature and pressure set values, because the temperature set value can be at a lower level or the pressure can be at a lower level, then that will affect the sterilization process. And also adjust the set sterilization time. If the set sterilization time is too low, sterilization will not be successful. Another problem is the machine not turning on. That can be caused by power failure or damaged power cords. So check the power supply integrity and check the continuity of the power cord, check the fuses and replace if damaged. Here in the picture, we are seeing the thermostat. That is what Daniel also mentioned, that it is the one that regulates the temperature inside the chamber. As you are seeing on the setting there, the temperature is above 150, but if you are sterilizing at 130, it should be in between 100 and 150, somewhere around there. And on the right-hand side, what you are seeing is the timer, where you set the sterilization time. So if the sterilization time is, let's say, 2 minutes, your materials will not get sterilized. So if it is 121, you put it at 15 minutes. If it is at 134, you put it at 5 minutes. So everything will be sterilized properly. Another problem is water not entering into the chamber. This can be caused by clogged pipes or faulty solenoid valves. So as a solution, you need to check if the pipes are clogged, then you unblock the clogged pipes and replace the faulty solenoid valve if it's faulty. Pressure higher than the set value. If the pressure is higher than the set value, you go straight and check the pressure switch, just because the pressure switch is the one that regulates the pressure. So if it is 40, then you replace the pressure switch or the pressure sensor. In the picture there, we are seeing the pressure switch, and we are also seeing the pressure sensor, and we are also seeing the solenoid valve. The other problem is the door not opening after sterilization. Daniel mentioned about this, and this can happen due to a faulty vacuum brake or an aeration valve. It can also happen due to a faulty door locking system, or there is pressure in the chamber. Because when there is pressure in the chamber, you will not be able to open the door because there will be too much pressure in the chamber. So as a solution, check the steam aeration valve. If it is faulty, replace it and test the door locking system. And if it is faulty, also replace it. And the pic on the right-hand side is the door locking system. If there is voltage there, the plunger is put inside. Once it is put inside, then you'll be able to open the door, and the door will be free to open. But make sure when you want to open the door, you check that the pressure gauge is at 0, because it's too dangerous to open the door when there is pressure in the chamber. Now let me take you through sourcing of spare parts and spare part management. The process of sourcing spare parts starts with fault reporting. And this fault is always reported by the user or the departmental head using what we call the maintenance request form. And after that, engineers goes to the department to do fault assessment, diagnosis, and that is done through visual inspection and testing to determine the fault. Fault identification is also done, and if the fault is simple, repair works starts right away. And if it requires some spares, then the ordering process of the spares starts. On the right-hand side there, we are seeing the equipment fault reporting form, where you put the name of the equipment, the area or the room in which it is housed, a brief description of the fault and the action taken. This action taken is the assessment and diagnosis. And the report reported by, it will be the one who reported the fault and reported to, and this is the engineer who received that particular request form. So the process of ordering spare parts begins with the filling of the internal procurement form. What we call it, the internal procurement requisition form. We call it the IPR. This IPR has some sections that shows the department requesting for the spare, the name of the spare, and the specifications. And on specifications, we need to fill the specs that will be in line with that particular 40 spare parts, because we might just order something that we may think it will fit on that particular point where we remove that spare, but with wrong specifications, and that will cause a problem on the functionality of the machine. Then lastly, on the IPR, we do have signatories, signatures for authorizing officers, that is from the head of department ordering that particular spare, the administration, the accountant, and the hospital director to authorize funds for procurement of that spare. After filling all the sections of the IPR, then the form is taken to the procurement department, and the procurement department do request for quotations from pre-qualified suppliers, or they float a tender in a newspaper for suppliers to bid. After everything, then the procurement department offer that contract to supply that ordered spare part to that particular supplier. So once the spare part is procured using the what we call it, the ORT, which is other recurrent transactions, that is the financial budget for maintenance of medical equipment, then the procured spare is then delivered to the stores for proper storage. And during the delivery period, the supplier will submit a delivery note, and the department receiving that particular spare part will issue what we call a goods received note. That is for receiving the spare part. Then they'll send a message to the engineers that the spare part has arrived, and the engineers will order the spare part from the stores and replace it on the machine. When more than one spare are procured, then remaining spares are entered into the stock cards and safely kept at the stores or at the engineering department stores. So if these spares are kept at the engineering department stores, they are reported into the inventory book, and also entered on the stock cards. Thank you very much for listening. That's the end of my presentation.
All right, thank you so much, our engineers, for the wonderful and informative presentation. Right now, I would like to open the floor to questions and comments. You can type your question in the chat, or you can raise your hand, and I will acknowledge you so that you can unmute yourself and ask the question. So right now, let me invite questions. So just raise your hand, and when you, right, yeah, I see a couple of hands. So I think James Ruhanga, you're first. So please unmute yourself and ask the question. And engineers, when you have the answer, just raise your hand as well so that I can actually hand over the question to you. Thank you. James Ruhanga, you can unmute yourself.
Thank you. Yes, I'm speaking from Tanzania, and I have two concerns. The first concern is that I've been having difficulties seeing the presentations together with the one who's presenting. So I was hoping that this material or reference would be posted somewhere, maybe in the YouTube channel or in the application, the BME Concert app. So I was hoping that this material will be posted there so that we can differentiate after the meeting. The second concern is about the device. I've been working on a device, a vertical steam sterilizer, and I've been finding a problem that after sterilization cycle is completed, the tools inside are coming out wet. So I was hoping that you could help me finding a troubleshooting such devices. that after sterilization, I find the tools wet. So thank you.
All right, thank you so much for that question, James Luvanga. I think we can take the first question. Yes, Engineer Daniel. If you are speaking, you are on mute. Can you try to unmute yourself?
Am I audible?
Yes.
Thank you, James, for asking that question. The vertical autoclaves, what you need to do, you need to put your packs within the vertical autoclave, and then at the top part, before you put on the lid, you need to get that green material, which is heat resistant. I know what we call it. You put it on top. It's just like a cover. You cover your packs. Remember that if you put the lid on the packs without that cover, that clothing, when you remove the lid, that vapor, it is in form of water. It falls to your packs and your packs are wet. So what is required after you have put your packs when you are loading, on top of it, before you put the cover, you get that clothing you put on top of the packs. Then you put the lid. You will avoid the wet packs. Number two, if in case you have put that clothing and you still find your packs are wet, check the loading system. You have overloaded your vertical autoclave. Number three, if you get your wet packs, it means some of your valves are leaking. Is it the safety valve is leaking? Is it the control valve is leaking? So that is very important. You check any of the valves is not leaking. You should also check the lid when you are closing it. If it is the vertical autoclave, remember you need to close the wing nuts, two opposite wing nuts at the same time. If in case you close the wing nut one following the other, it means there is no uniformity of the lid. And that means some part of the section of the autoclave, there is a leakage. And that leakage will lead to wet packs. So I think we shall give our emails also. If you have checked all those points and you still get wet packs, I think you can email us or you can WhatsApp for further diagnosis and further solutions. Thank you.
Right. Thank you so much, Daniel. I hope you got that clear, James. And I think I should also address on your first concern. You said you weren't able to see the slides properly. I want to assure you that you'll be able to find this webinar on the recording of the webinar on our YouTube channel, that is Oxygen Alliance YouTube channel. So be on the look. And also you have also pointed out that if we could have the webinar, the presentation on the DME on the app, yeah, for sure we are going to consider that as well. Thank you. All right, so we also have a hand from Foster and Mason. So Foster Center coming first, then we're also going to take the second question from Mason. Then the engineers are going to address these questions together. So Foster Center, we can come off mute and ask the question.
All right, thank you very much, Lloyd. Mine is simple and short. I don't know whether I missed it. I was joining from somewhere else. So my question is, I understand the bigger models of autoclaves usually offer an option of sterilizing with vacuum. So I wanted to understand what is the actual importance of sterilizing materials with vacuum, apart from just using heat or the normal sterilization process. Thank you.
All right, thank you. I hope you have taken note of that question. Let me give the floor to Mason to ask the second question so that you can take these questions together. You can come off mute, Mason.
Hello. I think you.
Yes, Mason, we can hear you. All right, so for Mason, I saw you posted a question in the chat. You actually asked about how frequent is the septic valve need to be calibrated. How frequent is the septic valve need to be calibrated? Yeah, so I think we got that question. I saw Engineer Bonongwe, you actually raised your hand. I'll give a chance to you to address the question as well.
Thank you very much. I want to respond to the question from Foster Sentala about the vacuum sterilization. Vacuum sterilization is not as vacuum sterilization as he has put it, but what happens is that during this sterilization cycle, there is the vacuuming process. And that vacuuming process is the process that removes the air that we close into the chamber when we are closing the door. So why do we remove the air from the chamber? It's just to make sure that there's nothing or it's completely a vacuum, so that when the steam comes there, you will not find any particular air inside there. Because this air that will be there will become like a barrier to the steam to penetrate into our sterilization packs. So the reason why we do vacuuming, or what we call it pacing, is to remove the air inside the chamber, so that when the steam is being injected into the chamber, there is nothing but only the sterilization packs. And that process of vacuuming happens in the first place when we are just starting the sterilization, and also at the end when we are doing drying. That is to remove air, so that whatever inside the chamber dries properly. So that is why we do having the vacuuming process. About the other question, I think someone might help me, but the calibration of safety valves, I think you can be checking it every year. That is annually. But if someone may have another suggestion, another idea, please, you are free to add. Thank you.
All right, thank you so much, Engineer Bonongwe. That was an elaborate answer on this question. So on the second question, still questions are coming up in the chat on the calibration. So the question, Kelvin has asked the question that how is calibration done? How can you calibrate these safety valves? So engineers, that's the question. And again, I've seen Good Luck Oboro has raised their hand. So we're going to take his question as well. So Good Luck, please unmute yourself and speak.
So thank you very much for the lecture. I want to ask on if you're using that tabletop type sterilizer, and most times it has indicator from when you fill in the water to the heating to the sterilization and to to heating and everything. So if it is not actually following, I mean the indicator is not actually following the the step, like a circle there. So what could be the possible faults? And again, when you're secondly, when the I don't know if the screen there is blank, what could be the possible faults? Thank you.
All right, thank you so much for that question, Gurek. I hope our engineers took note of that. He actually said that if an autoclave is just jumping phases, what can you do? Yeah, so Engineer Dan, you have raised your hand. Please take the question.
Thank you very much. When you find the cycle is not following one another, that is, we start from vacuuming, then steam admission, then sterilization, then drying, then airing, then end. If you find the vacuuming is not starting, then it means you need to check the vacuuming system. If after vacuuming, we need to admit the steam. If the steam is not forming, it means the elements, the electric heating elements are not able to generate the required heat to give out the correct steam. And that's why during steam admission, the steam cannot be admitted to the correct set point. Remember that all these steps within the sterilization cycle, they are timed. If it is vacuuming, it is timed. Is it 3 minutes? Is it 4 minutes? If it is steam admission, it is also timed. So it means if the evacuation goes more than the set time, that is more than 5 minutes, for example, it has gone to 6 minutes, it means that vacuuming system is not working. So you need to check that point. If the steam admission, it is also minuted, it takes long to admit the steam to the chamber, you need to check that line of the steam. And especially you check, are there leakages or not? If there are leakages, you correct. If you find there are no leakages, do we have enough water within the generating chamber? And if we have, in case we have enough water in the generating chamber, is the electric heating element generating the correct heat? Maybe there was a change of the electric heating element, and instead of following the correct technical specifications, if the electric heating element immersion type is 2 kilowatts, and then the engineer has replaced this electric heating element with 1.5 kilowatts, it means the process is going to be slow. And that the systematic following of the stabilization cycle will not be followed. When you find that the equipment cannot fill water to the correct levels, as the engineer said, you start from the pressure. Does the water has enough pressure? If the enough pressure is there, how are the tubings? Are they clogged or are they clear? You check. If in case the tubings are clear, do we have leakages within the joints? No leakages. Okay, what next? The most important with the tabletop autoclaves, you check the filters. The filters, after some time, they are blocked. When those two filters are blocked, the one inside the chamber, the one I showed you, you need to remove those filters and clean out with a brush. And at that time you are cleaning those filters, you need to clean them using the flowing water, main flowing water. And then you need to use a brush as you clean out the dust and dirt and soapy water. Until that, when you raise the filter, maybe facing the sun, you are able to see through the filter. Another point is that if there is air within the line, let's say there was some repairs, you emptied the water from the tank, let's say there were no main supply of the water through the line, and then the water came later, or maybe you have poured in the water, it means within the line of the water, there is air pockets. There is air within the system. So you need to remove that air for the system to be clear. How do you remove the air within the line? After the solenoid valve, you can release that crocodile clip and allow some water to go out. At that time, you mean you have eliminated any air within the system. And I think if you have done all those processes, the unit will have to work as expected. Thank you. When you get a blank screen, that means there is nothing on the screen. We showed you the fiber, which is connecting the main PCB board and the display board. That data cable, sometimes because of that, it will not be able to display. Or maybe you are able to see the display is on, the display is off. Sometimes that cable can be loose. Number two, that cable can be dirt. So as an engineer, what you need to do, remove the connector where it is connected from, take a brush and dust out the dust. After that, using the electronic contact cleaner, spray. After you have sprayed the electronic contact cleaner, give it like 2 minutes for it to dry. Once it has dried, now return back your cable. The same happens at the side of the display board, just at the rear of the display board. You do the same. You detach the cable, you spray using the electronic contact cleaner, you allow it 2 to 3 minutes for it to dry, then you take back your cable. In case you find you have done that and still the screen is blank, then there could be some issues with the display or with the display board. So you can change that display board. If in case the display board is okay, along or besides the display board, there is the light, which we call, and that light is comes with the light emitting diodes. If that light, it comes with a strip of light emitting diodes and it is put along the display board, rectangular, that form. So in case the LED light is not able to show, is the LED lights are not working, then you will not be able to see the screen. So there are several points, you need to check if the screen is not working. And if you find you have done all that and there is nothing you are able to see on the screen, then we recommend that you change that screen.
All right, thank you so much, Engineer Daniel, for that elaborate explanation. Really, we have learned a lot, and I believe good luck, that was so clear. So, with the interest of time, I think we can stop the webinar here. But then, before you leave, I've pasted a link in the chat where you can give us your feedback. So make sure that before you leave, you fill out this form so that we can actually hear from you. We can hear from our audience. So I personally learned a lot from the presentation, and I would like to thank the presenters for the wonderful presentation that you have made, and I would like to thank all the attendees of this webinar, and we hope to see you again on the 30th March for another technical presentation on bigger autoclave machines. So make sure that you set your calendars and make sure you don't miss this coming webinar on the 30th March 2025. Again, make sure to fill out the form before you leave the call. A link has been shared in the chat. Thank you so much for attending the call. Have a wonderful evening, all of you. Thank you so much.
Thank you.